this discussion continues to the inheritance. So eventually this inheritance or encapsulations are represented as programs, MATLAB code lines. But at this moment, we are discussing those MATLAB codes and MATLAB programs with diagram. And inheritance, so we discussed that in encapsulation, and we have this inheritance. Why don't you look at this picture? So this looks younger, this looks older. Seems like that these are son and father, right? Oh, sorry, father. And son inherits some characteristics from his father. For instance, right, this person has national register numbers, and this customer, by using this hollow point arrow, it inherits some characteristics and behavior, the data, and the functions. Okay, means that if customer inherits from person, customer, even though it doesn't specify here dash national registration number here, should have national registration number. And even though we don't specify login here, we should assume that because we are pointing at the hollow point from the customer to the person, we should assume that it has plus login function here. Employee class, same effect. It should assume that plus login function is here and national registration number is here, right? So inheritance means that giving my attributes to my descendants. My attributes include the member variables and methods, right? Those second box and third box. And my descendants may have new attributes such as ID and account number, like this, and request withdrawal confirm security card, etc. They might have new attributes, their own. And my descendants, my mask, the received attributes, they might refuse having national registration number or login. But if not specified otherwise, sons follow their father. Okay? And we have this one class, and we have another class, and we have also a hollow point arrow here, and we have person, and we have the otherwise we have customer and person. This part is called super class, because this is more generalized. Okay, this is more customized, so it's called sub class, because this is more specialized. Okay, so superclass is my ancestors and subclass is my descendants. These are all abstracts, right? In the week 1, we handled the actual MATLAB code. And you might puzzle, we don't have an actual code yet. So we are just talking with diagrams, and you want to see an actual things. You want to see an actual actions. So here it is. I coded the previous, I coded some the MATLAB code by using this UML class diagrams and its inheritance relationship. Okay, first thing, grandfather. Okay, grandfather obviously class. Grandfather is a class, right? And it inherits. This is inheritance. handle. Handle is the father of superclass of all objects in MATLAB. Okay? And this defines the reference class. In 99%, you want to use handle as an inheritance. So grandfather inherits handle, so and is handle. I'm not just drawing this particular handle class. And it has string hometown. It has properties string hometown like this, right? And we have two functions. We have two functions here. One thing is do grandfather thing and do running. And we have special class, a special function called constructor. Okay. Even though a constructor is not here, if it is a class, we should have constructor. And we briefly covered that in the week 1, part 3. Okay. In constructor, the format is this. This equal, and this is used here and here, right? Even though we don't have parameters here, if it is a reference class, we should add this in the parameter setting, okay? And then actual parameters comes later, here and here, here and here, if we have parameters for this particular function. Anyhow, we have two functions here, and that corresponds to these two functions. And we have constructor, which is not specified here, but class should have its own constructor. And we have this property, and property is listed here, and grandfather is here, right? And let's come back to the father, okay? Father, we have this father class, and it inherits things from the grandfather. This is the inheritance, comes from the grandfather, right? And it doesn't have any special properties. So we don't have properties. It's blank. But you may guess that it still have its hometown, because that otherwise specified this father inherits attributes coming from the grandfather, and that attributes include the properties and methods. And these methods include this do father thing, right? And this do father thing is here. And because it's class, it must have the constructor, right? Strangely, we have this do running here, right? And here it comes the masking. In the grandfather function, we have this do running, and do running displays very slow. In the father class, we have this do running, right? And it displays just slow. What happens is that if we instantiate this father rather than grandfather, and if we call the do running, what happens is that it displays slow. By masking this very slow. If we instantiate this grandfather, then if we call do running, then it will show the display very slow. Okay? And we are going to see that in this execution part, but we have another class to define, which is the child. Of course, this child inherits from the father. This father, right? This father is the superclass, and this child is the subclass. And it has a property, right? It's in the second box, so it's property. And it's the string name. It's string name, right? Like this. And in the methods, we have this constructor. And we have this method, right? Do running. Same thing, masking. Even though we inherit the do running from the grandfather, And father is masking it, and child is masking it. Means that if the instance is coming from this child, we are not going to learn this particular function. Rather learning this function, we are going to learn this function. Okay, so that we can display fast. What actually happens, let's observe that in this kind of execution part. So why don't you pause for a second and type in these three things, type in these three classes in your MATLAB script editor and save them. And then in your playground, in your main console, learn this me equal child, universe, and then do all these things. Then what happens is that me.do grandfather thing. It doesn't have do grandfather thing in the child class. It even doesn't have this function in the father class. This do grandfather thing belongs to the grandfather. But you know what happens? This do grandfather thing is not masked by the father and child, right? And this so that this do grandfather thing is going to be executed by using this cause. Okay, so that grandfather's actions are displayed. And do father thing calls these functions and father's actions executed, right? And if it calls do learning, then you know what? It calls the masked, the function. It doesn't go to the do learning here. It doesn't go to the do learning here. Doesn't execute this, doesn't execute this. Rather, it executes the child's do learning function. So it just displays the fast, right? And here, more important stuff happens here. So this constructor, child constructor, takes a single parameter called param home, right? If param home, if number of the arguments in is just 0, then this param home is equal to Daejeon. And this n arg in we are going to study later. And if param home comes in, then this at father actually calls what? The father's constructor, and param home is passed to here, right? And param home passed here, and then if number argument in is 0, which is not happening here, and we are going to explain this later, this param home happen the calls to the grandfather's constructor. At grandfather, something is so this add is this add represents the superclasses function, and superclasses function, and superclasses function, the grandfather is here, is constructor, so it goes here. And param home, the universe, this universe comes here, and it travels here, and it travels here, and it travels here. And then this grandfather constructor actually stores str hometown as the param home, right? And this string hometown will store this the universe. So display me.string hometown will display universe. Same thing, but little bit different thing here is this. This dot string name. String name is the properties of the child. Means that this string name will only possible or accessible if the instance is coming from the child, made from the child class. Anyhow, this me is created by child class. We can use that. Me.string name, and me.string name is coming from this moon, right? This moon is in the string name, so it displays moon. Okay. So why don't you pause for a second and type in these things and experiment it and then come back later. So now you know how to program, how to code in MATLAB programs, MATLAB classes, and you can create instances from the MATLAB classes by looking at these UML notations. Okay. And the next thing that I'd like to cover is more details about the MATLAB classes. Here, I'm pointing at the child and father. So, self is a reference about the class itself. Like inside of the child class, if you want to refer the child class itself, this can be called. So for instance, this child class has string name as property. And if it wants to use this string name within side of this function, it can call this dot string name. Okay, and then you can assign some values here. And if it is a reference class, you should put like this. The anytime if you want to do me dot something, right? So for instance, we have me dot do running here, and this me is actually refers to this. Okay, so you may wonder, for instance, if we have do running and this comma arg1. What actually you see in the execution part is me dot do running and arg1. Why is that? Because me corresponds to this and arg1 corresponds to this. Okay. I'd like to resolve your questions about kind of this question by using this slide. So this word this represents the child itself. Okay. And another thing that I'd like to mention is the super class. What if you want to access to these patterns of methods? In that case, what you want to do is this. You want to have like the object being instantiated and add. You want to add here, in Korean 골뱅이, add, and then you can call the superclasses a constructor here, and then you can pass the arguments here, right? And this is the more kind of general introduction of how you can call the superclasses constructor. Okay.